You know what time it is? It's time for calculus. Quadratic functions are U-shaped curves. They're commonly called parabolas. The major focus of grade 10 in the Ontario high school curriculum was these quadratic functions. You may have encountered quadratic functions in grade 9 or 10 science, or if you took a physics class after grade 10. You'll likely see them in commerce and economics classes here at Ottawa U. Let's start off by looking at some important features of a parabola. This is the focus. We don't care about the focus in university. The vertex is the lowest or highest point on the parabola. You may have studied vertex form in great detail in high school. Most profs don't care about vertex form, so we don't care about it either. These are the x-intercepts of the parabola. The x-intercepts are where the function intersects the x-axis. These are an important feature of not only parabolas, but many other functions. X-intercepts are important in this class. For any function, you can solve for the x-intercepts by setting y equal to 0, and then solving for x. Now that we've reviewed the basics, let's answer the most important question. What are you expected to know about quadratic functions coming into Math 1300? There are two major things. Number one, given simple quadratic equations, you should have a general idea of what they look like graphically and be able to sketch them. For example, consider the equations y equals x squared minus 4 and y equals 2x squared minus 1. Let's start out by drawing x and y axes. Pause here if you'd like to try the question yourself. The constant terms tell us the y-intercepts. The first parabola intersects the y-axis at y equals negative 4, and the second parabola intersects the y-axis at y equals negative 1. The coefficients in front of the x squared terms give us an idea of the relative steepness of the parabolas. These values can be interpreted similarly to slopes. When a linear equation has a high value of slope, the line is steeper. Here, when the coefficient in front of the x squared is higher, the parabola is steeper. Based on this information, we can make a rough sketch of the two parabolas. Note that profs will often tell you to sketch functions in this course. They're expecting you to label the x and y axes, but don't expect each individual x and y point to be labeled. You did that in high school and possibly grade school, but you don't need to show that level of detail anymore. An extreme level of detail is no longer required. Instead, labeling the important features is what is required. The expectations for sketching will be covered when you get to the curve sketching section of the course. Let's get back to our list. Number 2. Given a quadratic equation in standard form, you should be able to factor it. Let's try an example. Consider the quadratic function y equals x squared plus 5x plus 6. Pause here if you'd like to try the question yourself. Since the coefficient in front of x squared is 1, this quadratic function is easier to factor. We need to determine two numbers such that a, they add up to 5, and b, multiply to 6. The values x equals 2 and x equals 3 work. The order doesn't matter. In other words, you could also say x equals 3 and x equals 2 work. We can then write out the answer, which is the formula in factored form, as y equals x plus 2 times x plus 3, or in the other order, y equals x plus 3 times x plus 2. Another example, you say? Why, yes, let's try another one. Consider the quadratic function y equals 3x squared plus 7x plus 4. Pause here if you'd like to try the example yourself. Since the coefficient in front of x squared is not 1, and no common factor exists such that we can divide by it and simplify the function, this quadratic function is harder to factor. Here's how we do it. We need to determine two numbers such that they, a, add up to 7, and b, multiply to 3 times 4, which is 12. The values x equals 3 and x equals 4 work. Again, the order doesn't matter. In other words, you could also say that x equals 4 and x equals 3 work. Now we can simplify the quadratic function as follows. The 7x can be decomposed into 3x plus 4x, or vice versa. Then, the equation can be further factored by removing a 3x from the first two terms and a 4 from the last two terms. Removing the common factor of x plus 1 from both terms results in the final factored form. Note that if you can't factor a quadratic equation and you're completely stuck, using the quadratic formula is always a viable option. Ah, desperation. My old friend. Hey, it's Katrina from Prep 101. I really hope you enjoyed that primer. There's definitely more where that came from. Make sure to join the Facebook Study Hub for this course where you and your peers can communicate, ask questions about the course, and get access to free study aids. Use the link in the description box. I hope to see you at our prep sessions. I'll break down the course content for you step by step, show you how to solve actual exam questions, and maybe we'll get in a few laughs along the way. Many prep sessions for midterms are free. Yeah, free. Visit prep101.com for details. Thanks for watching. See you soon.